Nothing too crazy so far. So, what's important here is understanding the language, all right? Math is its own language. And I showed you some of the terminology yesterday, and now we're going to apply that terminology, okay? I'm going to give you some pieces of information. Okay, Bennett, what is this? What is this saying? It's a bunch of symbols and one word and a bunch of symbols. Can you interpret this into some meaning?
I don't know what the VR means, but I know that the QVP means like find the angle of
What does this symbol mean?
angle.
Angle. Okay. Angle QVP. QVP. There's your angle. All right. Someone help Bennett with what this means right here. Avery.
It's where it flips in half, right? The VR.
Aha.
Aha, right? Okay, so when you see it, this line with two letters that represent something from the this means this line segment that starts at V and goes to R. Okay? So do you see how this isn't even English? This isn't English or Spanish or what? This is math language. All right? Okay, let's say now I'm going to give you the problem here. Okay. Now, Bennett, translate this for us. What's this first part say?
If
And what's this little m right here? You guys remember from yesterday?
I don't remember.
The measure of. Okay, if the measure of angle PVR, here's PVR, okay?
So it means times the measure of the angle times PVR.
No, there's no multiplication, no operations here at all. This is strictly telling you something, all right? If the measure of angle PVR equals 5x minus 11, so here's angle PVR right here, and they're saying it's this many degrees. All right, Iris is really gonna like this.
What about this bit? It's just RVQ. There's no.
And yeah, it's okay. And the measure of angle RVQ, where's RVQ, JJ?
RVQ is
Right here?
yeah, R and then to the V and then to the Q.
Okay, you got this? You guys all okay with this? All right. If this angle is 2x plus 5, find the measure of this angle right here.
That's one below that. It is good.
Here, I need to put angles here. Measure angle PVQ. All right, this is what we're trying to solve for. Okay? Anyone have any idea where to start? Mac?
Well, the two are split down the middle.
How do you know that?
Because they're on either side of the line.
You know that these are split. How do you know these are split? There's some piece of information here that's telling you that. What is it?
I think
Oh,
it's the 5x.
No, no. There's something up there that's telling you that these two are exactly equal because this line is splitting it down. What's telling you that, Avery? Right here, okay? Important piece of information, number one, that you need. All right? Eli Beta? You see that? Thanks, Jamar. Okay. What does that tell you about the measure of these two angles? If this line is splitting this angle exactly in half, what does that tell you about these two? They're the same. They're the same measure. They have to be. Okay. How do we solve for the measure of this angle now? You guys have all the information you need. Can you set up a problem to do that? You just started it. You told me that this is equal to this. Didn't you tell me this is equal to that? Represent that mathematically. If this is equal to this.
We just write that out underneath it.
Write it out, man. Yeah. Write it out. So tell me, Maxwell, what you just wrote out. Okay, look at me here, Maxwell. We just figured out that this is equal to this. How do you represent that mathematically? If something is equal to something else, how do you write that?
Like 2x plus 5 is equal to 5x minus 1.
Perfect. All right. See, a lot of times you guys are or maybe just Maxwell's overanalyzing things. All right. All you have to do is that 2x plus 5 is equal to 5x minus 11. You see?
Would it be 7x plus 6?
Nope. Now can you solve this?
No.
Isaac.
Do both.
But do you want me to solve it right now?
Solve it. Have we learned how to solve these? Have we learned how to solve these?
Yes.
What do you do to solve something like this?
You subtract or combine like terms.
Combine like terms. Brilliant. And what's the first step? Or I mean, you can go in a couple directions here.
Combine. Subtract the 5 first.
7x equals negative 16. That's not right.
Let's subtract 5 like what Mac is saying.
Oh, wait a minute. Let's try this.
Okay. So you get 2x equals 5x. What's negative 11 minus 5?
Negative
Negative
16.
16.
Okay. Minus 16. All right, now let's get the x's on this side. Subtract 5x. All right, and that what's 2 minus 5?
3.
Okay. Negative 3x equals negative 16.
Then add 3 plus x. Yeah, x by itself. Or divide 3.
No, when you multiply.
Divide negative 3.
Okay, so we can just write, this is going to be positive 16 over 3.
Would it be negative 16?
But we divided by.
Oh, right.
Okay, are we done now? What did we just do?
Found the angle.
What?
Did we find the angle?
No.
What did we find?
We found what one side is worth.
Did we do that? Just look up here, you guys. Look up here. What did we find?
That actually doesn't.
Okay, we found. JJ, we found. Who said it?
X.
We found x. Is that what the angle is?
No.
All right. How do we find what the angle is?
Oh, we have to multiply those two. I'm gonna add them. What?
No, this angle is given to us in this parentheses. The measure of this angle is 2 times x plus 5. We just found what x is, so how do we find what this angle is?
What do you have to do? Like plug the number back in?
Plug the number back in. All right? And you guys all have practice with fractions. Okay, so you just plug the number back in, and that will give you the measure of that angle. Okay? This up here, there's more space. 2 times what we just solved for. Sorry, this is not equals. This should be an arrow. Okay? Alright, this one's going to turn out a little bit nasty because we're going to have to find a common denominator here, which is going to be 15. And then you'll be multiplying this 32 by 5. So you can we'll just leave this one here. Alright?
Go in.
What's that?
It doesn't go in the 32.
What do you mean?
5 doesn't go in the 32. Or 15 doesn't either.
Well, we're going to have to find a common denominator, which means we're going to have to multiply this by 5 on top and bottom, and this by 3 on top and bottom. Do you see what I'm saying?
Yeah.
Alright, so you're going to get a big number, 32 times 5 over 15 plus... Sorry. Do you see what's going on here?
Yeah.
This is 5 over 1. Does that help if I make it a fraction like that? 5 over 1? Or sorry, we'll have to multiply this by 15 actually. You see what I'm saying here? We need a common denominator. Yeah, go ahead. Okay, over 15 plus
15.
over 15, like that. Alright, find these numerators and then we can add it, and that's the measure of the angle. This one turned out kind of nasty. Alright, I'll do my best not to give you ones that end up like this, but at the same time, I don't want to regularly give you guys these problems that turn out like peachy. Oh, it's 32 degrees, like boom, on the dot. Or like, oh, x equals 6, or x equals 8, because then Iris will get used to that. And then I give her a problem with fractions, and she'll be like, wait a second, this isn't turning out the way that I'm used to, so now I'm not used, now I don't know what to do. Alright?
This was
I
our
want you
first
guys,
one, so-
in reality, what's that?
This was our first one.
This was your first one. Alright? In reality, problems don't work out like super perfectly, like nicely, and no decimals and no fractions. Alright? Mac.
Can you do just the same thing on the bottom and the same answer?
Same thing. It should be, because we set them up equal to each other, right?
Yeah.
Alright, so whatever you plug in here should be that.
Alright.
Okay? Alright, let's try another one. Yeah, it's gonna, you can leave it at that, finding the common denominator, and then we can just move on, because it's gonna turn out to be some big fraction. Alright. Let's try this one here. Same idea. Now I want you guys to do it on your own from start to finish and tell me what you get. And I found this in a book, I haven't even solved it yet, so when we solve it, we'll be solving it together. Okay, important information.
NK.
NR. Is there no N? Oh, VR.
Yeah, okay.
There we go. All right, this time find the measure of all the angles. Okay, go ahead.
All the angles added up or just each angle?
Each angle. So there's how many angles are in this picture? What is that?
3. That's 3.
Pretty sure?
Yep.
You're positive?
Think so.
Okay, tell me what they are. Using your now well-developed naming skills of angles that we've learned. 2 of them are already named for you on the board.
Arm. Oh. PV. Oh, that's what you're talking about? Like angles?
Mm-hmm.
PV and R?
PVR, not PV and R, but PVR is one angle.
Yeah.
Okay, what's the other 2 angles on here?
Is it Q at the bottom?
Yep.
QV R.
Okay, and then what's the third one?
Um,
Don't say it, Mac.
QVP.
Correct.
What
Okay,
about-
3 angles.
What about this thing?
No, that's not an angle because they're not connected.
I'm kidding.
Where's Aaron? What's
Aaron just doesn't feel like coming to school anymore.
I saw him walking. I walked in. Ollie.
You don't see Aaron over there in the corner?
Ollie, there's only the PV. The one
They don't pay attention.
Oh, no, that's right.
They don't pay attention.
Huh?
Hold
Hold on, you guys, I can't hear Avery.
We're trying to find the angle of the PVR and the RVP.
The ones that Isaac just told us. There's
But we
3
have,
angles to find the measure of.
we have 2. So we just
PVR, RVQ, and PVQ.
So we just need to find PVQs.
I mean, once you find PVQ, these are going to be the same, right? This angle is the same as this angle.
But you already have them right there.
Not the measure of it. I want degrees.
Oh.
Is it 30 degrees?
The V is the vertex.
This is, there's 3 vertices. Well, no, yeah, you're right. V is the vertex, but it just happened to be called V. I could call it L if you wanted.
Hey, Ollie.
Yeah, did you get it?
No, I'm just asking.
Does it turn out nicely? Did you do this one?
Yeah,
It does? Okay. Yeah, it looks like this one is not nasty like the last one.
So after I do this and I don't
I can't do it.
Super Mario.
That's right. Don't forget to label. What's 5? Okay, x equals 5.
What does that mean about these 2 angles?
Alright, don't forget to label your angles.
Ollie, I'm so confused what I do for the next one.
Alright, I'm gonna help you out right here.
I don't like the 5.
That too.
It's not you insert it.
Oh,
So now, we're gonna combine like numbers. I like
Then for these and the 3x.
Did you get this, Iris?
15.
I
You
choose that
inside the
for
half and the
Jamara, are you with us here?
11 plus 15.
TK, how you doing with the problem, man?
This one, 8 times
Okay, here, let me
11
help you out with
minus
it.
40.
Yeah.
So there
Alright,
goes 40.
Wait, so what does it do, Avery?
It's not 5, and you insert that x in this equation.
Wait, so 8 times 5.
8 times 11 plus 40. Or minus 40.
What? Wouldn't it be 8 times 5?
Yeah. Oh wait, yeah.
8.
Oh, that's why I was the wrong number. But yeah.
And that'd be 40, and then 40 minus 40. So
Wait.
that one just doesn't do anything.
I'll be right back.
There's nothing there, what do we assume it is? Positive, right?
It's 55 divided
Did you
by.
get the right answer?
I got 5.
Okay, make sure to label your vertex and these other 3 locations, those points, right? That's what's going to determine your angle.
Wait, that's right.
That's right, yeah, that looks good.
You just got the
That's right, yeah. You have, but he's taking it a step farther.
I have a 5x.
Oh, hold on a second. Let's see here. You get 55 equals 5x
Good.
divided by 5. Yeah.
So now you just plug that 11 in for your x.
Should be x equals 11.
And you
You
find
should
one
get
piece and there is
5x equals 55. I don't know where you're at. Oh, I see. You added 8 to that side. Whereas you should be subtracting.
Yes, ma'am.
Okay, you don't need a calculator. Chika, no calculators for this.
Okay, everyone gotta stop.
How you doing? Did you
stepping
get it?
on my foot.
Not there yet.
35's not right. You shouldn't have a 35 in here.
So if this one, if P, V, R is 48.
48.
Good. So what is P,
Alright,
V,
I
Q?
wrote a bit.
Alright,
What's the whole big
what does this information tell you? What does this mean right here? What does this mean? Bisects.
So we're saying in this.
We went over it. Oh, it's right here. Oh, bisect.
Together they make.
It does what? Okay, so this is split in half. What does that mean? What does that tell you about this and this? They're the same. If they're the same, set this equal to that.
Yeah, how do you?
How do you set it equal to it? You put an equal sign between them.
96.
Wait, JJ, what do you, let me see.
Alright, Jamara, Iris, step 1 is right here. Okay? Step 1. Did you get this far? Did you get this far? Iris. Okay?
Yeah, okay.
Step
What's
2.
step two? I don't even know what step two is.
Solve.
And then you add.
Oh.
Alright, subtract 15 from the left. Subtract 15 from the right. You get 3x equals 8x minus 55. Subtract 8x. Subtract 8x. You get negative 5x equals negative 55. Okay, divide by negative 5. Iris, are you with me here? I don't want to go too fast if you haven't done this yet. Okay, you too, Jamara. Maxwell,
I've done it.
you've done the whole thing?
Max, a bit of.
Okay. All of this right here is nothing new. You guys, this is combining like terms and solving for x. This is what we did last unit. Alright? What's new is applying this logic. Alright? Isaac, can I get you back in your seat? Can I get you back in your seat too, please? Okay. What did you get for x? X equals 11. Alright, but we're not done. Okay? Last unit we would have been done here. X equals 11. Alright? Good night, God bless, go home. Alright? But we're not done.
3x times.
What do I need to do, Iris?
11 plus 15.
What is it asking me for? Okay, find the measure of all angles. And we just found x. How does that help us find the measure of the angles?
You have to plug it back in.
Okay, you gotta take this and plug it into x right here. We found x, right? Okay, so if we plug 11 into here, then we'll get angle, what is it, PVR? Angle PVR equals 3 times 11
Plus 15.
plus 15,
And then that equals 48.
33 plus 15.
And then you times that by 2.
800.
Okay, PVR. Alright, we found angle PVR.
But
Okay.
times it by 2, right?
Now it says find measure of all angles. Alright, what's RVQ?
Same. It's
48.
gonna be the same.
It's gotta be the same.
Oh, no, we have to
So then you add those two together.
And then-
96 degrees.
Correct. Alright, QVP is 96 degrees. Alright, we just found all 3 angles. Any questions how we got there?
No.
Can you do this on your own from start to finish? Eli B?
Heck no.
You just read it all over.
Okay, you guys know how to do the math here. Alright? What's new is the system. Alright, this is a new system that we're presenting. Alright, here are some angles. Here's the algebra. Can you put them together to find the measure of them? Okay. Let's try one that's a little different. I've got a couple like this, but I want to do a different one. Can I erase all this?
Yeah.
Yeah. Wait, no. Oh my God.
Off round.
I'll leave that bit right there.
That's a size small. That's a small.
Very small.
That is very small.
All right, this is a diagram.
You're like 5.
This is a diagram of an airport runway.
Whoa.
No,
That
5'8".
helps. Makes it.
I'm 5'4".
You're 5R.
I'm 5'9". How can I like the same height? I'm not 5'7".
Okay, eyes up here, you guys.
Maxwell.
Here's a diagram of an airport runway, a CTAP, all right? And what airports like to do is to name their runways in degrees, going clockwise, and they drop the 0.
Why?
Okay, I don't know why they do it, but they drop the 0. Okay, because they all have a 0 in common, they're just like, we don't need the zeros, we'll just drop them. Okay, so this one would be how many degrees? 360 degrees. Okay, what about this one?
90.
And what about this one? And,
270.
okay, where does it start? Where's degree 0?
The middle.
Middle.
The middle.
No,
Bottom. Middle.
The top.
360. Okay, if you spin 360 degrees, you've gone in a complete circle.
So,
Okay, here's the problem.
you get mad.
SeaTac wants to add a new runway labeled 32.
Why?
New run.
You have enough runways, man.
Okay, draw where it would approximately be.
Oh shoot. With a new day comes new strength and rods.
Okay, and then B, because the runway is going to be pretty long, alright? What number would be on the other end of the runway?
Well,
What?
Pretty long.
Is it just a part of the road?
Obviously.
Or is it a completely new road?
Do we have to write the first runway?
Nah.
Oh my lord. Well, I'll just do it anyway. We have to write like the a new
You can write as much of this as you want, alright? If you just, as long as you have A and B, then I'll know what you're talking about. Okay, so first approximate, alright? Approximate where this runway will be. Okay, degrees. You're working degrees, alright, around this circle. Where would 32 be about?
Be like between
In
like
between
27 and
27 and
36.
36.
Correct. Okay, in between 27 and 36.
What would we write then?
Friday's coming up close.
It's Tuesday, TK.
That's close. I think it's close.
It's like 4 days. Is it?
We're counting this one. It's like 3
It
days.
It's gonna fly by fast.
Not
I bet.
bad, that'd be weird.
Well, I'm counting. It's really early in the morning. It's like another 4 days.
Yep. No, slow down.
So here's the new runway. It's gonna come in like this, and it's gonna go out like that.
12.
Tell me where you got 12 from.
Well, I got it from 2 things. One, just a random guess,
Okay, that's not gonna do it.
and the other one,
Okay, use math. I want you to use math. Alright, I don't want you to randomly guess.
Randomly.
You can use somebody's, you guys, use logic, alright?
Wait,
How do you,
Wait, would it be 14? How about 14?
tell me where you got that from.
Well, because 14 is a 4 away from 18, and 32 is 4 away from.
Okay, he's using the right logic. Your logic is not flawed. The problem is that this isn't 36 degrees and 32 degrees. What is it actually?
320 and 30.
320 degrees and 360 degrees. Okay? If this is 320 degrees, this is 360 degrees, how far apart in degrees are they from each other? 40 degrees. This is 40 degrees right here.
40.
Well, those are also, if it's 14.
Now do you guys see? Jamara, do you see? Hold on, Jamara. So how do I find what to label this runway now? So we found the difference here. What do I have to, where do I apply that?
plus 4 or something like that. Would be 22.
Not quite.
18.
180 degrees minus 40 degrees, and then 90 degrees plus.
Just that's all you need right there. Okay? JJ just said it. All right? 180 degrees minus 40 degrees.
It's 40.
What's that?
They're all good.
It's 100.
Oh, I get it now.
Okay? Because this is a straight line and this is a straight line. All right? So from here to here, 180 minus 40. All right? So what did you say it's going to be labeled?
JJ said it was 14.
14 is
What
right.
did you say though, Mac?
I said 12, but JJ said it was 14.
14 is right.
So JJ was right.
Weird, man.
Well, haters who didn't believe me.
Interesting problem, right?
That was fun.
I'm going to ask you one like this on the quiz. Yeah. Iris, did you follow us here? Okay. To make it a little bit easier on your eyes, we can actually draw it just like this with lines. Okay? If this is 40 degrees, then this is also 40 degrees.
Everything's also 40 degrees.
Okay?